Good morning. In the previous part, I discussed the issues of properly selecting a heat recovery ventilator. In this part, I'll address the most common mistakes that can be made at the design stage or during the installation of a heat recovery system. Execution errors, meaning issues related to design and discussed with the contractors, yes, but things don't always go perfectly. We would like it to be that way, but there is a certain group of mistakes that are the most common because most complaints about poorly functioning heat recovery systems are related to bad design and poor installation. The most common complaints are, the system is noisy, the air coming from the supply is too cold, or water is leaking. This is related to a lack of insulation, poor insulation, or the ventilation system being installed in the wrong place. In other words, again, bad insulation. When it comes to noise, it's caused by ducts that are too small or not enough ducts, right? So the air comes out at too high a speed. So those are the two main issues, noise and water, right? Or low temperature. That's what I mentioned earlier, just as a reminder, right? Proper installation of a ventilation and heat recovery system means the entire system is placed within the warm zone, that is, the heated and insulated area. If we ensure that, then the only remaining issue is noise, which really comes down to limiting the air speed in the ducts. A few examples, starting with this first one, which is an exhaust air diffuser, probably in a kitchen or bathroom. On the other side, there's nothing, no insulation, none of that, so the air in the pipes, meaning the water in that air, condensed and returned to this point, which means it flooded our supply air point. This is an issue related specifically to the tightness of the connection. Here we have, in this case, this is the intake duct, so if the nipple or the connection stub is installed incorrectly, warm, humid air gets into the intake duct where it meets the cold outside air, causing water to condense. The water then freezes on the filter, forming an icicle on the filter. Or, if the stub is poorly insulated, water will run down the outside, which again could flood the device from the outside, possibly reaching the control board, the electronics, or the automation system. We've already talked today about insulation, and the question is regular tape enough? No, it's not enough. It will give way. And when the tape gives way, air will get into the pipe, water will condense from the air, and again, it will start leaking. Or the last example, I don't know what to call it. I don't know how to describe it. Someone just threw the entire installation up into the attic. From the distribution box, the pipes branch out chaotically without any thought. So in this case, the ventilation unit was designed for 500 meters. They barely managed to reach 300. The first example is related to the heat exchanger. I wasn't able to repeat that. The heat exchanger is installed at a 90-degree angle, so the flow is blocked, there's no heat recovery, and the device works poorly. I wasn't able to install it. Someone managed to do it. There's a tape on the heat exchanger, a mounting tape, or rather, let's call it a transport tape. This tape is there so you can remove the heat exchanger and install it correctly. Another common mistake, I don't know what causes it, but it's using the wrong device in the wrong place. Here, for example, we have a case of installing a Type V ventilation unit in the attic where, if it's going to be in the attic, the ventilation unit should have side-mounted ducts. with horizontal ducts. But here, the device is too tall, so the airflow is immediately restricted, the resistance is too high, there might be a lot of noise, and for sure, the fans will consume too much electrical energy. The installation is set up in the wrong place. Here, it seems like everything is perfect. Yes. The only thing, a suspended ceiling frame to be installed underneath this. These pipes were to be lowered onto that frame and then covered with insulation. That wasn't done. The insulation was put in, but at that point, the pipes were actually halfway inside the insulation. So there was already heat loss, which meant that while the room was 21 degrees, the exhaust was at 17. That's already a 4-degree difference, right? A difference, and in the other direction, another loss, right? So from 17 degrees, let's say it was 15 at the heat recovery unit, so what could flow into the room was 13 or 14 degrees. That's not what we wanted, right? When it comes to heat recovery. So if anything, like I said, let's install it on a drywall frame. That's an option, so let's use it, right? Other issues related to poor installation, like pipes nailed or attached to the attic, to the boarding, right? So where's the insulation? It's under the pipes, not above, just under. So again, the pipes are basically in a cold zone, right? So water is going to leak there, 99% for sure. This is something to avoid, meaning collisions with other installations. If we have a design, let's discuss it with other installers, with other teams, so that we can fit everything within that acoustic insulation layer on the floor. A very common question is whether you can install a heat recovery ventilator in the attic if you enclose it in some kind of igloo-like box, or if you make an extra room for it. Yes, you absolutely can, but that igloo must be properly insulated, and there also needs to be an additional heat source inside the igloo to compensate for the heat loss from inside it, because the heat recovery ventilator itself does not generate heat. So it can happen that even if you have the igloo, the temperature inside will be the same as outside the igloo. If we don't compensate for those heat losses in some additional way, whether it's electric heating, water-based heating, or any other method. And then there's the issue of further insulating or adding insulation to the ducts and pipes, depending on the ambient temperature in the rooms those pipes pass through, right? So when it comes to connecting the supply and exhaust, if we're dealing with temperatures up to, let's say, plus 20 or plus 15 degrees, with EPS ducts we don't need to do anything extra. But in the case of steel pipes, we could add at least 2 centimeters of lamella wool insulation. For the next range, between 14 and 1 degree, we recommend an additional 5 centimeters of low insulation, right? To install the supply and exhaust system in this setup, and if we're already moving into the cold zone, needing an uninsulated, unheated attic, then in reality that's the outside temperature, so at least 20 centimeters of wool insulation plus up to 50, right? So in reality, the thickness of the insulation would have to be at least 250, but the optimal solution would be if the insulation thickness was 40 centimeters. So we end up with something like this. A 200 millimeter pipe, 40, that's already a meter. So if we have the option, let's avoid installing systems in unheated, uninsulated attics. Let's get into the warm zone as quickly as possible. With EPS ducts, it's a similar story, similar requirements, but really, it's only when we get into an uninsulated attic that we need to add extra insulation. When it comes to supply, exhaust, and the exhaust vent, it's to protect against condensation. For supply and exhaust, we need to protect against heat loss during transfer, and for the exhaust vent, we protect against water condensing inside the duct. If you can see the insulation wool on flexible ducts, then 99.9% of the time that wool will get soaked, and that duct will have to be thrown away. If you can see the metal spigots on the intake duct, water will definitely condense there, it will drip, and it will run down the device. If we're already using steel spiro ducts or pipes, let's make sure to insulate them, at least when it comes to supply and exhaust. Here it's a similar story, but it's also about how the heat recovery unit is connected to the system. Let's avoid connections like a flexible duct that's immediately bent, for example, 180 degrees. Let's make sure, or even require, that the outlet from the heat recovery unit has at least 50 to 70 centimeters of straight, rigid duct, and only after that can we start adding bends, elbows, and the rest, right? Fans have their own limitations when it comes to resistance and output. Maybe it's not such a big mistake, but in the Rico series ventilation units, we have 2 filter inlets, so an additional box. If the filters are not removed from the heat recovery unit, will create extra resistance, which means we might once again fail to achieve the desired performance. Okay, that's all when it comes to mistakes. I invite you to the next stage of the course, which is the practical part, where I will discuss the individual stages of installing a heat recovery ventilation system at a sample construction site.